Hello, welcome to another episode. In this episode, we are going to talk about kinetic energy of rolling object. Okay, that is what we are going to break down in this episode. Before that, could you please like, share, and then subscribe at this video? That will help me a lot. So let's proceed with the how to find out the kinetic energy of a rolling object. Okay, ከዚህ በፊት እንደምታውቁት ስለ rotational motion discuss አድርገን ነበረና in that episode we did discuss about how to find out the kinetic energy of rotational motion. Okay, that is basically our initial point. So what we can do is the kinetic energy, as you know, that the kinetic energy of rotational object is equal to rotational motion of an object is equal to 1/2 multiplied with the angular, the moment of inertia multiplied with angular velocity square, right? That is a kinetic energy of rotational motion of an object. Okay, in our case we are going to talk about this rolling body or this rigid body. This is a kind of rolling object. Okay, so with the axis or with a pivot point or with a rotational point P. Okay, so we are going to take the point P as a pivot or axis of rotation. Okay, now this is, like I said, this is an initial point for to find out how to find out the kinetic energy of a rolling object. Now what we can do is, as you know from the parallel axis theorem, what we can do is that moment of inertia or a new moment of inertia is equal to moment of inertia at the center of mass plus with the moment of mass time radius. This is a parallel axis theorem. This is parallel. Let me write here. It's a parallel. Sorry about that, guys. Parallel axis theorem. Okay, this is a parallel axis theorem. That is what we call it. Like I said, parallel axis theorem. We are using a P because our pivot point is P. Okay, that's why we are using a P. So what you can do is now we can plug this equation over here. Okay, now kinetic energy of rolling object will become that 1/2. Okay, 1/2. Open the bracket. You can plug, like I said, this guy over here. Now you will get central moment of inertia as a center of mass plus m. This guy is r square. I'm sorry about that, guys. So r square, and then this is r square, then multiplied with angular velocity. Okay. Now what we can do is we can just multiply this guy. So kinetic energy is equal to 1/2. 1/2. Okay, this is 1. Center of moment of inertia as a center of mass plus multiplied with angular speed plus 1/2. Okay, 1/2 multiplied with mass multiplied with r square and then omega square, right? That is it. And then as you know that the relationship linear velocity as well as the relationship from the linear velocity and angular velocity, you know that v in our case the center of v, right, center of mass of v is equal to angular velocity multiplied with r. Okay, that is from the relationship between the speed or linear speed as well as the angular speed. Okay, now you can plug this term over here. Now you will get kinetic energy is equal to 1/2. Okay, 1/2 in central moment of inertia multiplied with angular speed plus 1/2. Okay, this is 1/2 multiplied with the mass, and then this guy is over here, which is linear velocity, right? Linear speed. So that is it. Basically, that is how to find out the kinetic energy of the rolling object, meaning that this term indicates that a translational motion of this object as well as this guy is indicated that the rotational motion of an object. So that is all about this session. So let me know if you have any question in this episode. You can feel free to put your question in the comment section. I'm happy to reply for you guys. So like I said, could you please like እየታያረለም please like አድርጉ or share አድርጉ ቲክቶክ ላይ ከሆናችሁ you can share with your friend as well as please you can share in YouTube as well. If somebody is in YouTube, you can uh, share the link in the YouTube as well. Yeah, like I said, that is all about today session, and then see you in the next episode. Have a good day. Enjoy your day. Thank you.